Now we're going to look at some more properties of trig functions, and specifically we want to look at distribution. In other words, and you can see in this example, can we distribute sine to the same thing like we did with real numbers, right? We know that if we had, say 3x plus y, we could distribute the 3 and say this is 3x plus 3y. Is the same true with trig functions? So we know that sine of 1 or pi over 2 is equal to sine of pi over 4 plus pi over 4, right? So the question is, can we distribute this, right? So sine of pi over 2 is 1, right? Use your unit circle as the y value at 90 degrees. And then if we evaluate this, this is, so sine of pi over 4, that should be square root of 2 over 2. And then we add it again. So we end up with, if we simplify this, 2 square roots of 2 over 2, which is just square root of 2, which if you punch this in your calculator, it's about 1.4-ish. So are these the same? No. So in general, okay, if we have something like this, is sine of pi over 2 is not equal to sine of pi over 4 plus pi over 4, or sorry, that is equal to, but it is not equal to sine of pi over 4 plus sine of pi over 4. Okay, so trig functions cannot be distributed across addition or subtraction, okay? But yet there is a formula that we can use that looks at angle addition, and you can see them here, okay? If you want, you can go through a big, long geometric proof of these in some textbook. The old textbook that we used to have it on page 579. It's in most textbooks. Go look it up if you so desire. But the main thing that we need to pay attention to are the formats, okay? So notice that these first two deal with sine, okay? That's fine. As we analyze them, so it says sine of u plus sine of v is equal to sine of u, so sine of the first angle, and then plus sine, so it'd be plus v times cosine v, okay? And then they switch. So in the second term, it is now cosine of u and then sine of v, okay? And also keep in mind the signs between them. So plus and plus, minus and minus for sine, cosine, it is the opposite. So plus goes to minus, minus goes to plus. Okay, so we're gonna have to spend some time working with these patterns. Sine for me, I remember as it's sine, cosine, cosine, sine. It's just what has stuck in my brain over the years. Cosine, the pattern I remember is that if I have cosine of a sum of angles, it'd be cosine, cosine, and then sine, sine. Okay. Again, for some reason it works in my brain. Feel free to remember it how it best works for you. Okay. The other thing that I'll mention, you see the formulas for tangent? Yeah, they exist. Okay. I can tell you in my professional career, I don't think I've used them once because typically you just translate them back to sine and cosine and work with them there. Okay. But nevertheless, if you need them, they're there. So some examples. We want to find the exact value of each expression. So you're like, well, I don't see a sum, right? I don't see two angles. U and V here have to be angles, okay? Where are my two angles in sine of 75 degrees? The trick is force it. Make the two angles appear. Okay, so I want to view this as sine of something plus sine or plus something and then use the formula. Okay, now you might scratch your head and say, well, there's a lot of things that add to 75. And I'm going to say, be clever. Use angles that you already know that add to 75 that are nice from the unit circle. 30 degrees is pretty nice. And if I add 45 to it, that gives me 75. Okay. So figure out what nice angles from the unit circle will work for you. Okay. So then in this case, I use the formula for angle addition here. So it'd be sine of 30 plus sine or plus 45 is equal to sine of 30, sine of the first, cosine of the second, and then plus cosine of the first, plus sine of the second. Okay. And so then now, what do we do from here? Answer, use a unit circle. So sine of 30 is 1/2, cosine is square root of 2 over 2. Multiply those and then add that to cosine of 30 is square root of 3 over 2, and then sine of 45 is square root of 2 over 2. And then if I simplify that, I'd get square root of 2 over 4 plus square root of 6 over 4, which is fine. And I would just write it all as a common denominator of 4 and then square root of 2 plus square root of 6. And that's that. Okay, so we have one example down. Again, we just had to look for the two angles. Let's see if we can do that again with cosine. So again, I'm going to say, take a moment and pause the video. Try and break this cosine of 195. Split that angle up into two nice angles that we already know from the unit circle. Okay, so I think I would do it as cosine or as 50 degrees and 45 degrees. Okay, and so then now I just have to use the correct formula. So cosine, and then I have a plus in the middle, so that's going to be this formula, right? So it'd be cosine 150, cosine 45, minus sine 150, sine 45. Okay, go ahead and evaluate. I get negative square root of 3 over 2 times square root of 2 over 2 minus sine of 150 is 1/2 and cosine is square root of 2 over 2. Okay, and so here I get negative square root of 6 over 4 minus square root of 2 over 4. Oops, forgot the negative. And so then in all, denominator 4, negative square root of 6 minus square root of 2, and I'm done. Okay, so after you find the angles again, just use the unit circle to evaluate. All right, now we're going to do something a little bit bizarre. We're going to go in reverse of sorts. So we have cosine of 99 plus, and then cosine 36 minus sine 99, sine 36. So automatically I see it's cosine, cosine, sine, sine. So my attention is drawn to those two formulas. And I notice that if I have minus in between, that corresponds to the first one. Okay, so instead of expanding it out, right, I can't evaluate 99 degrees and 36 degrees, or I guess the trig functions at those angles, right, easily. So instead, I'm just going to treat this as cosine of, and then it would be 99 degrees, so I'm going backwards. Cosine 99 degrees plus 36 degrees, which is cosine of 135 degrees. And that all simplifies to negative square root of 2 over 2 if I use the unit circle. Okay, so be aware that you can use these formulas to expand, right, as we did in the first two, or contract via this last example. Okay, so be on the lookout for those, and make sure to really spend some time thinking through or working through examples with these angle addition and difference formulas.